Hello everyone. Today our learning target is I can multiply monomials. Okay, so a monomial is one of our vocab words, and it is a single term expression with no adding or subtracting, just multiplying and or dividing. Okay, so you might have numbers and variables, and a lot of times that they will have an exponent. Okay, so let's review a few things about exponents. So this here we would call b to the x, okay? Where b is our base and the x is our exponent, okay? So we could say that as b to the x, b to the power of x, b raised to the x, something along those lines, okay? So now we are going to consider the following monomials and write them in a condensed form. Okay, so here we have 3 times 3 times 3 times 3 times 3. Okay, and we have 1, 2, 3, 4, 5 threes. Okay, so we would call that 3 to the 5th. Okay, because there are 5 threes. Now for this next one, we have 1, 2, 3, 4, 5, 6 x's. So we will make that x to the 6th. Okay, and we have 1, 2, 3 y's, which gives us y to the 3rd. Okay, so we have x to the 6th, y to the 3rd. Now we can't combine those and make it xy to the 9th because they're different variables and we don't know what the values of those variables are. Okay, so now let's talk about the product of powers. Okay, product is going to be another one of our vocab words this week. And you remember what product is. Product is when we're multiplying two things together, right? And the answer that we get. So in this one, we have 3 to the 7th times 3 to the 2nd, okay? So if we have 3 to the 7th, that gives us 3 times 3 times 3 times 3 times 3 times, that's 1, 2, 3, 4, 5, times 3 times 3. Okay, 1, 2, 3, 4, 5, 6, 7 threes. And then we have times 3 to the 2nd. Okay, well, that's times 2 more threes, right? That's what those exponents mean. Okay, so all together we have 1, 2, 3, 4, 5, 6, 7, 8, 9 threes. Okay, so we have 3 to the 9th. It's our final answer. Now we could write down that that is equal to 19,683, but we're just going to leave it as 3 to the 9th for right now. Okay. Then for this next one, we have 6n squared times 2n cubed. All right, well, we know that multiplying is commutative. Okay, it has the commutative property, which means that you can do it in any order, right? So if you're multiplying everything together, you can switch up the order. So I am going to switch up the order of this one, and we are going to take the 6 times the 2 and put those next to each other. And then we're going to do the n squared times the n cubed and put those next to each other. Okay? Here, let me just fix that a little bit. N squared times our n cubed. Okay, so we can do 6 times 2. We know that that is equal to 12. Okay, so we know there's going to be 12. And then we have n squared times n to the 3rd. Okay, well, when we wrote out all of those 3's in that last one, we ended up with 3 to the 7th times 3 squared gives us 3 to the 9th. Well, with that, we took that 7 and that 2, and we added them together. So we're going to do that with this one. So we'll take that n squared times the n cubed, and the 2 plus 3 will add those, and we'll get n to the 5th. So our answer here for this one is 12n to the 5th. Okay? All right, well, let's just keep going. So now for this next one, we have 3p t squared times p cubed t to the 4th. Okay, well, that p there, that doesn't have an exponent. That's really like p to the 1, right? So there's nothing that we can multiply by the 3, right? So we'll still just have the 3, okay? And we're looking at our like variables, right? So then we have p to the first times p cubed, okay? So that gives us p to the fourth total. P to the fourth, okay? And then we have our t squared times t to the fourth, which will give us t to the sixth. Okay, so our answer for this one will be 3p to the fourth, t to the sixth. Okay, and then finally, for this last one, we have a negative 4 in our first term and a negative 6 in our second term. So we're going to multiply those. So negative 4 times negative 6, which gives us 24. Okay, then we have an r, which is really r to the 1, right? Okay, so r to the 1, r to the first times r to the fifth, which gives us r to the sixth. Okay, and then we have x squared times x squared, right? So we add the 2's, get x to the fourth, and then a t cubed, and then this t is also t to the first. So we have t cubed times t to the first, which gives us t to the fourth. Okay, so we get 24 r to the sixth, x to the fourth, t to the fourth. Okay, so our rule here is to add the exponents when you are multiplying two monomials with the same base. Okay, so we'll add the exponents. So we might also see a power of a power. So a monomial raised to a power. Okay, like for example, this first one. Okay, so we have c squared cubed. Okay, well, this is like saying we have c squared 3 times, right? C squared times c squared times c squared. Okay? So we have c squared times 3 times. Okay, well now we just have a product of powers, right? So we have c squared times c squared times c squared. Well, that's c to the sixth. Okay? You can look at this next one. Now we have a power to a power to a power. So we have 2 cubed squared. And then that's all to the fourth. So we have 2, forgot to grab the pen. Okay, we have 2 cubed times 2 cubed, right? And then that's all still being raised to the fourth power. Okay, so, well, we have 2 cubed times 2 cubed. That gives us 2 to the sixth. And we know that that is to the fourth. Okay, so we have 2 to the sixth times 2 to the sixth times 2 to the sixth times 2 to the sixth. Okay, so that gives us 2 to the 24th as our total, as our final answer. Okay. Then we can look at this one down here. We have v squared squared to the fourth. Okay, well, let's look at kind of what we did up here. So with c squared to the third, we ended up with c to the sixth. Well, 2 times 3 is 6. Okay, let's see if that same thing happens with this one. All right, well, we have 2 cubed squared. Okay, so we have 2 cubed squared, it gives us 2 to the sixth. That's still that 3 times 2. Okay, and then 2 to the sixth to the fourth. Okay, that gave us 2 to the 24th. Well, 6 times 4 is 24. So our rule here looks like we are going to multiply the exponents. Okay, so if we have v squared squared, well, that's v to the 2 times 2, which is 4, right? And then that's being raised to the fourth power. Okay, so that's v to the fourth, which gives us v, well, 4 times 4 is 16. So that gives us v to the 16th. right? And then looking at this one here, we have 3 squared cubed. Okay, well 3 squared cubed, that's 3 to the 2 times 3. Okay, so that's 3 to the 6th. Let me just fix that little guy there. So that's 3 to the 6th. Then we have that to the 4th. Well, 6 times 4 is 24, so we know this is 3 to the 24th. So like I said earlier, our rule, if we have a power of a power, is to multiply the exponents. Now we also might have a power of a product, which would mean multiple monomials raised to the power. So for example, in this one, we have all of these different things inside the parentheses that are going to be raised to our power. Okay, so we'll start with negative 2 to the 5th. Okay, so we have that, negative 2 raised to the 5th power. And then we have x raised to the 5th power. Well, that's really just x to the 1st, right? So x to the 1st raised to the 5th. Well, that gives us x to the 5th. Okay, and then y cubed to the 5th, right? We multiply those exponents, so that'll give us y to the 15th. Okay, so here in this one, we end up with negative 32. Okay, negative 2 to the 5th. We can just put that in our calculator. X to the 5th, y to the 15th. Okay. Now this one's a little bit different because we have a fraction, but we've seen those before. So we'll have 4 over 7 raised to the 2nd power. And then m raised to the 2nd power. Again, that's m to the 1st. So we have m squared. Okay, and then again, we have this 4 over 7. So we square both parts of the numerator and the denominator. So we have our 16 over 49. And that doesn't simplify any further, so we'll just leave it like that. And m squared. For this next one, we have a few more steps. So we have to cube that inside part first and then square all of that. So we'll have negative 2 cubed, which gives us negative 8. Negative 8. And then x to the 1st cubed, which is x cubed. And y squared cubed, we multiply those exponents, gives us y to the 6th. Okay, and then we have all of that squared. Okay, well, negative 8 squared, that'll be negative 8 times negative 8, two negatives multiplied together to make a positive 64. And then x cubed squared, we multiply those to get x to the 6th, and y to the 6th squared, multiply those and get y to the 12th. One more of these. 1/2 cubed. Well, that's 1/2 cubed. And then a squared cubed. We multiply them to get a to the 6th. Same thing with b squared cubed. Multiply them to get b to the 6th. Now 1/2 cubed, we cube the numerator and the denominator. Well, 1 cubed gives us 1 still. 2 cubed gives us 8. You can use our calculators for that if we are unsure. A to the 6th, b to the 6th. And we can simplify this slightly more because this 1 on top, we can just put our a to the 6th and b to the 6th, multiply those across because those are all in the numerator. Right, it's like this is over 1, this is over 1, we're multiplying all of these. Okay, so we can get this to equal a to the 6th, b to the 6th, all over 8. Alright, now simplifying expressions, putting it all together. These ones will have a few more steps. Okay, so if we look at 3xy to the 4th and then negative 2y squared, that all cubed. Well, 3xy to the 4th, there's not another exponent outside those parentheses, so we'll just keep that for now. Okay, that negative 2y squared, and then that is cubed. So negative 2 squared is going to give us 4, and y squared is y squared. Okay, and then that is all being cubed. And remembering our order of operations, we always have to do exponents first, right? So we'll take this 4y squared cubed before we combine it with that 3xy to the 4th. So 4 cubed, well, that's 4 times 4 times 4. If we plug that into our calculator, that gives us 64. And y squared cubed, you multiply those exponents to give us y to the 6th. So that's what we have over here. And then we're multiplying that by 3x y to the 4th. Okay, well 3 times 64, that gives us 192. X, well there's nothing to combine with over there, so we just still have that x. And then y to the 4th times y to the 6th. Well, now we're just multiplying them with like bases, so we add the exponents. Give us y to the 10th. Okay, one last one here. We have 1/2 cubed. Well, we did that one earlier. We know that that's 1/8. And a squared cubed is a to the 6th, and then we have b to the 6th, b squared cubed. And then in this one, we have negative 4v squared, negative 4 squared, negative 4 times negative 4 is a 16, and then b squared is b squared. And then we have that cubed. So over here we have 1 over 8, a to the 6th, b to the 6th. And we have 16 cubed. We can do that in our calculator. That's 4,096. V to the 6th. We multiply the 2 and the 3 there. Well, okay, so let's look at our numbers. Here we have 1/8 and 4,096. Okay, so we can do 4,096 times 1/8. That gives us 512. Okay, and we don't have any more a's, so we just have a to the 6th. No more b's, so b to the 6th. And no more v's, so v to the 6th. And that is our final answer. Thanks for watching, and have a great day.